Hey Algebra 2, here are the notes for 13.5, Law of Cosines. So, let ABC be any triangle with A, B, and C representing the measures of sides, opposite angles with measures A, B, and C respectively. That's just the triangle I've built here. The law of cosines, in case you have forgotten since geometry, is the general form A squared equals B squared plus C squared minus 2bc times the cosine of A. Now, mathematicians were like, no, we want a law of cosines for each side. We can't be happy with just A squared. We also need to write the same equation for B squared, where we just change out the letters even though it says the exact same thing. And then even another mathematician was like, no, it's not good enough if you don't do it for all of them. So unfortunately, we have to write another one. But the cool thing about these is they all say the same thing. And if you can remember the pattern with them, it's really easy to memorize them for any reason. You always have the same letters on the outside. Think of those as your bookends. Then whatever letter isn't on the outside, those are the two that go in the middle. And they go in the middle 2 times. So if you can remember the general form, the letters will come naturally. So let's now use this. The first case is when we have 3 sides. We start by finding the largest angle. I'm going to shorthand, so find the largest angle. Once we've done that, law of sines to find everything else. To solve triangle. Remember, to solve a triangle means to find any missing pieces. That means sides or angles. The second case we're going to use it with is side angle side. And notice this angle is included. It has to be included, otherwise we can't use it. Here we're going to start a little differently. We're going to find the third side using law of cosines. I'm going to shorthand law of cosines. And then, again, guess what? We're going to use law of sines to find the smallest angle. All right, so the first example here is really hard to see. First off, I am so sorry for the poor printing, but we've got a triangle with a side length of 24, 18, and then down here is 57 degrees. So you might want to rewrite that so you can see it. And then, of course, we've got an A, a B, and a C. This is a little c in case you were curious. So what case do we have here? Well, we have a side, an included angle, and a side. That means we're going to do case 2, and we're going to start by finding the third side using law of cosines. So, law of cosines says c squared must be equal to a squared plus b squared minus 2 times those again times the cosine of the angle we're looking for. In that case, that's 57 degrees. All right, now we can calculate this, but don't throw it all in your calculator at once. It'll cause a lot of issues. We're going to do this in little baby steps. So 24 squared plus 18 squared is equal to 900. 2 times 24 times 18 is negative 864 cos 57. And now that I have this and I've simplified it this way, now I want to put all of this into my calculator at one time. And by doing it this way, you're going to avoid a lot of the errors that I've been seeing. So 900 minus 864 cosine 57. Again, make sure you're in degrees. That will cause problems if suddenly you somehow got into radians. We hit equals. Pause. Why is this not my answer? This is huge. It doesn't even make sense. Well, if we go back, we have to remember that it's equal to c squared. So in order to get c, we have to take the square root of the answer that we have. When I do that, I find that c is about 20.7, which makes a lot more sense than the bag 429 that I had before. All right, I now have this. Once I found the third side using law of cosines, I can use law of sines again to find everything else. So I'm going to do that, draw a little line here. I set up my true pair of sine 57 over 20.7 and say it's equal to sine of A over 18. Do my little calculations and do 46.8 degrees. Now that I have that, I don't have to set up another law of sines. I can just say 180 minus that and find that if A is equal to 46.8 degrees, then B must be equal to 76.2 degrees. And that's all there is to it. We've solved the triangle. So if one case was an SAS, the next one must be a triple S. Hey, lucky for us, it is a triple S, so we get to see one of that example. Let me just darken this triangle for us so you can see it. There we go. And the numbers aren't bad on that one. So if it is an SSS, the first thing we do is find the largest angle. In this case, that's going to be A. So I set it up. I know if I have to have cosine of A on one end, that the other end must match up. So my 15 must be what I square on the left side. Everything else then falls into place. Minus 2, 7, 9 times cos. All right, again, don't just throw this in your calculator. Your calculator will get mad at you. So let's do it in chunks. 15 squared is 225. 7 squared is 49, plus 81, which is 9 squared, is 130. Minus 2 times 7 times 9, which is 126. Cos A. Don't subtract these. I already have seen people do it. Subtract these first. We want to get cosine A by itself. So 225 minus 130 equals 95. Then we're going to divide it by that negative 126 to get it away from the cosine. Divided by negative 126. And once you get here, I don't want you writing down cosine A equals all of this. That's a waste of time. Just hit second cosine second answer and hit enter. And that will give you what A is equal to. You have to be strategic with your calculator. It can be a tool, but it can also throw you way, way off. All right, now that we have found the largest angle, we can just use law of sines. Sine 138.9 over 15 is equal to sine of whatever angle, let's do C first, over 7. Calculate it out. I find that C ends up being 17.9 degrees. I then subtract that and 138, and I find that B is equal to 23.2. I know I went through that really fast, so pause the video, go back and listen to it again if you need to, or shoot me an email with questions you have on how I did that. But once I found it, just make sure you box those answers for me again. Speeds up grading significantly. If you don't do a real great job of showing me what is what, I don't always catch it. All right, one more. So an anthropologist examining the footprints made by a bipedal two-footed dinosaur finds that the average pace was about 1.6 meters. So the pace is 1.6. It says the average stride was about 3.15. If I have three sides of a triangle and I want to find theta, I have to use law of cosine. So that's what I'm going to do. 3.15 squared equals 1.6 squared plus 1.6 squared minus 2. 1.6 times 1.6 is just 1.6 squared again, times cosine of theta. All right, let's do a little simplifying. 3.15 squared, 9.9225 equals 6 squared times 2, 5.12 minus, that's just going to be twice that, so 10.24 cos theta. Simplify it, move it over, divide by 10.4, and then do the inverse of cosine. So I get 4.8025 when I subtract it over. Then I would divide by that 5.12 to get cosine theta by itself. And then when I plug it in, I end up getting theta equals 159.7 degrees. All right, last one. Let's take a break from calculating and use our logic skills. So let's just not even look over here yet. Let's glance at this triangle. This is an SSA triangle. We know that we can only use law of cosine for the SSS and SAS. So we instantly know that we have to start by finding it using law of sines. So whichever one of these starts with law of sines is going to be right. So let's read them. Begin by using the law of sines. Since you are given two sides and an angle opposite one of them. Is that true? Yeah, we decided law of sines worked, and we have an angle with a side opposite one of them. I like Mateo, he works for me. But let's check on Amy to make sure she's on the same page. It says begin by using the law of cosines. That is wrong. We decided that sines had to come first. Then she says, I think this since you are given two sides and their included angle. Here's the problem. 30 degrees is not in between 22 and 23. So I would say, if I was grading her paper for a grade, I would say 30 degrees is not included. So this doesn't work. Amy is not correct in this instance. All right, let me know if you have any questions.